Welcome to Excel and Business Math video number 42. Hey, in this video, we got to talk about simple interest and short-term loans. That means the bank or some other institution is going to lend some money, and then later you're going to have to pay it back plus interest. Now, here are our topics, and simple interest calculations and formulas are much different than compound interest. Now, we'll talk about compound interest in next video, but this video we want to see the exciting topic of how to make calculations for simple interest. Now, we got to start off by going over to the sheet debt and interest. So I'm going to click on DI. What is debt? It means you owe money or it's a loan. Synonyms: debt, loan, liability, owe money. All of those mean that you owe somebody some money. Example, you borrow $100 from the bank lends you $100. This means you owe $100 to the bank, plus interest, as we'll see in just a moment. Now, in this video, the debt we will look at is short-term loans, usually 1 year or less. Now, what is interest? You can think of it as rent on money. Now, technically, it is a contractual fee charged to borrow money. That means it's all about what it says in the contract. Now, if you are the borrower, you pay interest to the lender. If you're the lender, you get or earn interest from the borrower. Now, from 2 points of view, the borrower, well, the bank lends you $100, and 1 year later you pay back $110. But you pay interest on the debt of $10 in this example. The lender, same two things. The bank lends you $100. 1 year you pay back $110. But the bank earns interest on investment of $10. The calculations we make can be either side. You could be making these calculations as the borrower or as the lender. Now, we need to go over and talk about terms. I'm going to click on the sheet Terms. Here it is. Here's a simple example of what is known as a promissory note. And we want to talk about the different terms we might see for loans in general, and for us in this video, short-term loans in specific. Now, principal, that's the word that means loan amount, amount borrowed, the amount lent out, or the amount invested. From the borrower's point of view, it's debt. From the lender's point of view, it's an investment. There it is, the same word for both sides. Here in our promissory note, there's the principal. Interest, what is it? A contractual fee charged to borrow the money, rent on money, as we said. But there's two different ways we can calculate interest: simple interest and compound interest. Now, simple interest, interest paid on principal only, usually used for loans less than 1 year. But all loans are based on contracts, so there are all sorts of different types of contracts. And sometimes simple interest can be used for long-term loans. But mostly in business, simple interest is used on loans less than a year. In our simple example, there's the principal, there's the interest rate. So the simple interest that you would pay if you took this out not for 12 months, but for 24 months, meaning 2 years, you'd simply take 10% times 100, which is $10. So for simple interest, your total interest paid in 2 years would be $20. Now, compound interest, interest paid on principal and past interest, also known as interest on interest, usually used for loans more than a year. Now, if we did compound, which we'll do next video, instead of paying simply $20, you'd actually have to pay more than $20. And we'll talk about how to make those calculations next video. Now, interest rate, it's always going to be some percentage of the principal that the borrower must pay back as interest. The maker or payer or debtor or borrower, that's the person borrowing the money. Here, the borrower is Sue Radkulinator. And Sue signed her name down at the bottom. Payee or creditor or lender, That's the person lending the money. In this example, BECU, Boeing Employees Credit Union Bank, is the lender. The term, that's the length of time until the loan is due, given in days, months, or years. Now for us, our calculations will be different if the term is given in days, months, or years. Down here, we could see the term for this was 12 months. So our unit that we'll use for our calculations is months, not days, not years. Now the issue date, that's the day the loan is made. Maturity date, that's the date that the principal and interest is due. Down here, there's the issue date, 3/31/2017. Maturity date, that means they have to pay principal and interest, 3/31/2018. Maturity value, that's the term they use for principal plus interest that's due on the maturity date. Promissory note, well, that's this right here. And there's always three components. A promissory note is a legal document in which a person or firm agrees to pay to another a stated amount of money, that's the $100, plus interest computed at a stated rate, 10%, at a stated time in the future. Now, this promissory note lists the maturity date, but oftentimes it doesn't. It'll list the issue date and the term, and then you have to calculate the maturity date. All right, now we want to go over to the sheet formulas and talk about our formulas. We have our one basic simple interest formula. The simple interest is calculated by taking the principal times the rate times the time. Now, I, that's simple interest in dollars. That's that amount right there. P, that's going to be our principal amount borrowed in dollars. That's it right there. R, it is going to be an annual simple interest rate percentage. There's the R. T, time, and it's always going to be this T right here, time as a fraction of a year. That means if we are not given time as a fraction of a year, for example, we're given days or months, we're actually going to have to calculate the fraction of a year. So if time is given in months or days, you must convert it to a fraction of a year. It's not hard. For fraction of a year from months, we simply take whatever the months are. For example, 4 months, divide it by 12. That'll tell us the fraction of a year. Fraction of the year from days, exact method, banker's method. You mean there's two different methods? Well, not so much anymore, but there used to be different methods. The method we're going to use for all examples except for one will be the exact method. And this is the common sense method that we would all automatically do. We'll take the number of days divided by days in the year. Now, sometimes there's a leap year every 4 years, so you might have to use 366 in the denominator. Now, the interesting thing about this calculation right here is you got to read your contract. For example, many credit card contracts do not list 365 or 366. They list 365.25. So that way they can use the same denominator every year. In essence, what they did is they took the one extra day, divided it into 4, and added 0.25. So this is exact method. There is something called a banker's method. And that's when you use 360 in the denominator. Yes, the advantage for the banks of using a smaller number in the denominator is it will inflate the fraction of a year. If they have a longer fraction of a year, they can get more interest. Now, they don't do this so much anymore. In fact, almost all consumer loans use something like 365 or 366 or 365.25. You will see 360 still used, for example, in the bond market, which is a government debt market. But for us, I'll show you one example, and then we'll never do it again. Now, if we are solving for interest, well, of course, we do P times R times T. But what if we're solving for R or T or P? Well, guess what? We get to use our same circle diagram as we did back in our part base rate videos. So for solving for P, you look at this diagram and you take interest in dollars in the numerator. And in the denominator, you have to multiply rate times time. Now, here's the formula right here. In Excel, we'll have to put parentheses around the rate times time to force the multiplication before our division. If we're solving for R, interest divided by principal times time. And if we're solving for time, interest divided by principal times rate. Now, if we're solving for time, remember, this will yield the fraction of a year. So when we're doing our formula for time, yes, fraction of a year, we simply take interest and divide it by principal times rate. But guess what? That's fraction of a year. If we want to bump it back up to months, then we have to take this, the fraction of a year, put it right there, and simply multiply it by 12 to get it back up to months. If we're doing days, we simply take fraction of a year and multiply it by whichever is the correct number of days you're using. Now, we want to go over and look at our first three examples on the sheet, fraction of a year. Now, on the fraction of a year sheet, we have three examples. And notice time is given as 1. That means a year. Here, it's a half a year. Here, it's 3/4 of a year. So our calculation is simple. Principal times rate times time. And I'm going to use the round function. All the criteria are not met for using round because we're actually not going to use this in any subsequent calculation. But I do want to emphasize that oftentimes with these calculations, you do get fractions of a penny. But here it is. Principal, that's the P, times simple annual interest rate, that's the R, times fraction of a year, time, comma, 2 because we're rounding the penny, and close parentheses. Now I'm going to Control-Enter. I could see it calculates 10 bucks. Just as we expected, we probably could do this one in our head. Remember, as we've talked about through 41 videos so far in the class, when we see 10%, that really means for every $1 there, please give me 10 parts, which is 10 pennies. So if we take out 10 pennies for every one there, we get 10 bucks. Now I want you to look up to the formula bar or just hit F2. Notice those are relative cell references, so Control-Enter. I'm going to copy this because the templates for these down here are exactly the same. So when I click in cell B13 and use Control-V to paste, of course, it got it right. I could hit F2 to prove it. The relative cell references are working. And of course, for a half a year, we get charged simple interest dollar amount of $5. Down here, notice the dancing ants are still dancing, so I can simply Control-V to paste it again. And there it is, $7.50. Now, normally we don't get it as a fraction of a year. We get it in days or months. So let's go over to the sheet, months and days. Here's the formula we're going to use, including the correct calculation to get fraction of a year, which is our T. All right, let's scroll down. Example 5. If you borrow $4,500 at an annual simple interest rate of 6.5% for a 9-month term, what is the maturity value and what is the maturity date? Now, I've already listed all of the variable names and our variables. Principal, that's the P. Annual simple interest rate, that's the R. Notice this is time in months, and I like to put the unit off to the side just to remind myself that's months. Now, the loan issue date is 11/21/2017. There's our base formula for calculating interest. Now, time. Well, if we have 9 months, we need to divide it by the total number of months in the year to get fraction of a year. Equals, there's the 9. And guess what? I'm going to hard code this in. Divide by, and then there it is, 12. 12 is not a variable that's going to change. So I simply hard code it into our formula. We are not violating Excel's golden rule there. And enter. So 0.75. We can calculate our simple interest amount equals the round tab. Arrow up, principal P times. There's the rate for the whole year. But now we need to take less than the whole year. And what fraction of the year are we going to use? 0.75. In essence, that fraction of a year takes the full amount and takes 3/4 of it, or 0.75, comma 2, close parentheses, and enter. So $219.38. Now maturity value, that's the amount that's due in total in 9 months from the issue date. Well, that's going to be maturity value, principal plus our interest, and enter. Now loan maturity date. We actually have done lots of date calculations in this class. We've seen e-date a bunch of times. E-date is the function you want to use when you have a particular date and you want to move forwards or backwards a certain number of months. So equals e-date will come to our rescue. Now remember, we have to use e-date because we couldn't just take 9 times 30, 270 days, and add it because each month doesn't have exactly 30 days. I take the start date, comma, and months. That's how many months you want to jump forward in our case, or backwards if you put a negative number. Close parentheses, and there it is, 8/21/2018. And of course, the beauty of Excel is if that actually was not 9, it was 6, I could simply type 6 and enter, and everything updates. Now I'm going to Control Z on that. 9 months. Now let's look at our next example, example 6. If you borrow $150,000 at an annual simple interest rate of 6.75 for a 180-day term, what is the interest paid for both the exact and banker's interest methods? What is the maturity date? All right, so I listed the variables: principal, annual simple interest rate. There's days. That's time in days. Loan issue date. Now the exact method, fraction of a year. This is days, equals 180 divided by 365. Now actually sometimes, and actually later examples, we'll put this as a variable in a cell. But if all your contracts are 365, we can go ahead and hard code that in as assumed variable that will not change. So there it is. The fraction of a year is 0.4931, etc. Now, before we do the interest calculation, let's just do the banker's interest fraction of a year, and we'll see why bankers many decades ago used to do this. Now, I'm going to take the same exact 180 days and divide it by a smaller number, 360. Because 360 is smaller than 365, when I hit Enter, the resultant decimal is bigger. That's what someone who wanted to maximize interest would want. They would want to take the interest for a half a year instead of only 0.49 of the year. Now let's make our interest calculations and confirm that, in fact, there is more interest using the banker's method. I'm going to take principal times the full annual rate for the whole year times the fraction of a year, comma 2, close parentheses. Now when I hit Enter, so 4,993.15. Now let's do it for half a year. Equals the round. There's our principal times annual simple interest rate, and then we multiply. There it is, the fraction of a year, but that's a bigger fraction of a year, comma 2, close parentheses, and Enter. And sure enough, 5,062.50. So that's about $70 more. Exactly the same term, but a different denominator. So that's the one time we'll see this. If you're a business person doing short-term loans, you're probably not going to see that unless you buy some government debt. Now the maturity date. We do not have to use e-date because that is a serial number date. We talked all about dates earlier in the class. We can simply add numbers to it, and it will tell us whatever this day is plus 180 days in the future. When I hit Enter, that's the maturity date. So we owe this on 1/7/2019. All right, let's look at example 7. If you borrow $18,500 at a simple interest rate of 7% for a 10-month term, what is the maturity value and the maturity date? Now, I don't even have here a cell that I set up to calculate the fraction of the year. Because if you're really just interested in the interest, we can go ahead and calculate it all in one step. Remember, we have to take the principal, that's the amount that we borrowed, times simple interest rate for the whole year, but we didn't take it for the whole year, times what fraction of the year? 10 months divided by hard-coded in 12. Now notice we do not have to put parentheses around it because Excel will calculate it from left to right. Comma 2, close parentheses, and enter. So our interest, $1,079.17. Maturity value, the principal plus our interest, and enter. The loan maturity date equals, well, we're dealing with months, so let's use E date. I love E date. It makes it so easy. There's the start date, comma, and how many months do we want to jump into the future? 10 months. It'll give me exactly our maturity date. Example 8. If you borrow $18,500 and an annual simple rate of 7% on 9/14/2017, and you pay the loan back on 1/12/2018, what is the maturity value and what was the term of the loan? Interest calculated using exact method. Well, we listed our principal and our annual simple interest rate. Well, we are missing the term, but no problem. We can do date math. We have the loan issue date and maturity date. We simply do our date math. Later date minus earlier date. And when I hit enter, we know 120 days. That means we can calculate our interest that we need to pay. There's the principal times the rate for the whole year times the fraction of a year. Well, we have days. We're using exact method divided by 365. Comma, 2, close parentheses, and enter. 425.75. Our maturity value, principal plus our interest. And there's the maturity value. All right, so on this sheet, we saw 4 examples of calculating the actual interest, maturity value, and loan maturity date when our term is given in months or days. And now we want to go over to the sheet PRT. And on this sheet, we want to see how to solve for principal, rate, and time. Now let's scroll down. We'll solve for principal. We'll see one with days and one with months. If you pay $225 in interest, the term of the loan was 90 days, and the annual simple interest rate was 8.75. What was the original borrowed amount principal? Use the exact method. Well, we've listed our variables. Simple interest rate, 90 days. Oh, look, I put 365 as a variable into our cell, and there's the interest. Fraction of a year equals, there's the 90 days. We're using exact, so I'm going to divide by this 365. Now we have to solve for principal. We can look at our diagram. There it is, R&T in the denominator, interest amount in the numerator. Equals, there's the full interest amount divided by, there's our annual rate times our fraction of year time. But that formula will not work because it'll do the division first, and we don't want that. So you have to make sure, force our multiplying to occur first. When I hit enter, there's the principal. I'm going to round this, and I'm doing it in 2 steps because if I want to check, I better not use the rounded amount. So there it is, 10,428 and 57 pennies. If I want to check, I can use any one of the other formulas. I'm just going to calculate the interest. Well, there's the principal, the unrounded amount to check and get the exact answer, times the rate times the fraction of a year. And when I hit enter, there it is. We've checked 225. Now, here's example 10. If you paid $110 in interest, the term of the loan was 4 months. So this one, we have months, not days. The annual simple interest rate is 5.25%. What was the original amount borrowed, the principal? There's the rate. There's the term, 4 months, and there's the amount of the interest. We always have to calculate time as a fraction of a year. Hey, there's 4 months divided by, I'm just going to put that 12 since it'll never change, right into the denominator. So 1/3 of a year. The principal, well, we still take interest and we divide it by, in parentheses, there's our rate times the fraction of a year time. Close parentheses and enter. I can round that, round to the penny, so we use to close parentheses. So there it is, $6,285.71. We figured out what the principal was, given that we knew what the interest was we paid, the term, and the interest rate. Now we can check this. Equals, well, there's the principal times the rate times whatever the time is. It's a fraction of a year. And sure enough, 110 bucks. So solving for principal, there it is, interest divided by rate times time. Now let's go solve for rate. And here's our formula. We're going to solve for that one. So that means we take interest in dollars divided by, in parentheses, principal times time. 50,000 for months and $1,000 of interest. Fraction of a year equals, well, there's the 4 months divided by 12 and enter. We're solving for the rate. Equals, well, there's the interest in the numerator divided by, in the denominator. There's the principal times whatever the time is. Close parentheses and enter. 6 pennies for every $1. If we apply our general number formatting, home, drop down general, or use our keyboard, Control-Shift-tilde grave accent, there it is, 0.06. We could add a percentage number formatting if we'd like. I'm definitely going to check it. I'll just use the interest formula, equals, hey, principal times, there's the rate I just calculated, times the time, fraction of a year. And sure enough, 1,000 bucks. Now, example 12, if you borrow $2,500, pay simple interest of 10 bucks. We have an issue date of 11/22/2021 and a maturity date of 12/12/2021. What was the simple interest rate? Well, first, we have our principal. We have our interest. We have the two dates, later date and earlier date, so we can calculate the number of days. There's the later date minus the earlier date and enter. So 20 days. Do people actually take out loans for 20 days? You betcha they do. Sometimes just for a day. There's all sorts of different short-term business loans. We need to calculate fraction of a year equals 20, and we're doing exact, and I have 365 in the cell, so I take 20 divided by 365. That's the time we can use. Now, the annual simple interest rate equals the $10. That's the interest we paid divided by, in parentheses, there's the principal times the time. Close parentheses and enter. 7 pennies for every $1. Control-Shift-tilde grave accent. Oh, look at that. I'm so glad I wiped away that number formatting because it's actually 7.3%. Now I'm going to check with our interest formula. There's the principal times the rate times our time, and I better get 10 bucks, and sure enough, I do. All right, so we saw 2 examples of how to solve for rate. Now time. Time's always the one that's a little bit tricky just because we have to convert from days and months to fraction of a year. Here's our formula. We're solving for time, so it's going to be interest divided by principal times rate. But remember, that calculation will give us the t, which is fraction of a year. So if we want that, that's good. If we don't want that, we want it in months, for example, we simply need to multiply it by 12. If we want it in days exact method, we take fraction of a year and multiply it by 365. We might have to round also since we're dealing with days or years. All right, this example, if you borrowed $1,450 at a simple interest rate of 4.5%, and the simple interest you paid was 50 bucks, what was the term of the loan in days? Use exact method. All right, so 1,500, 5%. Uh-oh, look at that. I'm so lucky I know that number formatting is a facade. I'm going to go up and increase the decimals. And sure enough, that was decreased decimal, making it look like 5% when it really underneath was 4.5. Simple interest paid, 50 bucks. Let's calculate our fraction of a year. Equals, there's the full interest divided by, and there are three things in the denominator: principal, rate, and time. I'm solving for times. So what do I need? I need the other two, the principal times the rate. Close parentheses and enter. I'm going to wipe away the number formatting, Control-Shift-tilde. That applies general number formatting. Now that's the fraction of a year. If I want it in days, and we're using exact, I say, hey, fraction of a year, I need you to bump up to total number of days. So I multiply it by 365, and sure enough, I get just under 280. So I'm going to round this, F2, round. And you know what? It depends on what the contract says, whether we're rounding up or down. I'm going to use the round, which will use the normal rounding rule. If you always wanted to round down, you would use that one. If you always wanted to round up, you'd use that one. I'm using round, comma, 0, close parentheses, and enter. So 280 days. Now I'm going to check using my interest formula. So there's the principal times the rate. And I don't want it for the whole year. I want it for the fraction of the year. And when I hit enter, 50 bucks will work. Exactly the same. All right, example 14. If you borrowed $4,800 at an annual simple rate of 8%, and the simple interest paid was 160 bucks, what was the term of the loans in months? Well, fraction of a year equals, in the numerator, that's the total interest, divided by, and there's three parts. Since we're solving for time, I'm going to, in the denominator, take principal times rate, close parentheses, and enter. 42 pennies. I'm going to click there and Control-Shift-tilde, grave accent. Wiped away the number formatting. That will be our fraction of a year. Now, months equals up arrow. That's fraction of a year times 12. Control-Enter. It happened to give me exactly what I wanted. I didn't have to use round here if I wanted to make sure in all cases that it rounded to the nearest integer. I would use 0 and enter. I could check this. Equals principal times rate times fraction of a year. That's the time, and enter. 160 bucks. All right, so that's our last example. And there are 10 awesome homework problems for you to practice. Now, in this video, we saw how to use the standard simple interest formula. We actually saw how to solve for time. We saw how to solve for rate. We saw how to solve for principal. Back over on the sheet months and days, we saw examples of how to calculate the actual interest, maturity value, and loan maturity date given a time in months and a time in days. We even compared and contrasted exact interest and ordinary banker's interest. And we started off over here with some simple formulas when you're given actual fraction of a year. Now, if you like that video, be sure to click that thumbs up, leave a comment, and sub, because there's always lots more videos to come from excelisfun, including next video number 43. We'll talk not about simple interest, but compound interest. All right, we'll see you next video.